Hello everyone, this is the recorded presentation because we all authors are based in Canada and according to the time slot it is almost the midnight when we are supposed to present, so we are sharing our recorded presentation. In case you have any questions, I will provide you the email at the end of this presentation and you can email us. So we are going to present the work on risk assessment of gas pipelines failure in Vietnam. Our group is consistent of Windao, Zaman, Sajid, and Yoi Zhang. We belong from Faculty of Engineering and Applied Science in Memorial University of Newfoundland, Canada. This is the table of contents for our presentation. We will work on what are the objective and the scope of the work. We will provide some introduction, what is the risk analysis of natural gas pipelines operation. We work on a case study of the Vietnam, and then we'll discuss our applications of the methodology, what are the finding and conclusions of from this work. Now, in terms of energy requirement in the Vietnam, it is very important to understand that industry is developing in Vietnam and energy is the foundation of the modern industry and sustainable development of the economy. In this scenario, the natural gas pipeline transportations are the most important parameter to understand when we are talking about the energy. So the natural gas pipelines are defined as basically a pipeline that transports natural gas from production site or treatment plant to an urban gas distribution center or industrial enterprise users. Now technically there are three gas transmission pipelines. It could be a gathering pipeline, it could be a gas transmission pipeline, or it could be a gas distribution pipeline. Now, when it comes to the safety of these gas pipelines, including oil pipelines, we have some challenges available. The first challenge is they are of the very large volume, these pipelines, and they work on a very high pressure. They are very easily corroded by the natural gas. There could be some leakage accidents which can bring very serious safety risks. And to avoid the various types of the safety accident or all the level improve the safety of the natural gas transmission, it is important to study the safety aspect of these pipelines. And last but not least, to ensure the human health and reduce the environmental pollutions, the safe operation of oil and natural gas pipeline transportation is very important. Now these are the objectives of our work. We have a very big project that we are working on, and this is just a small part of that project that we decided to present in this conference. Our first objective in this work is to develop a risk assessment model of the natural gas release in offshore gas pipelines in Vietnam. And the second is to analyze the causes of the gas pipeline failure and evaluate the level of uncertainty. And this is our technical objective here. Accident in natural gas pipelines may cause fatality and substantial economic loss. Considering this, our objective is to develop a risk assessment methodology for the failure of the gas pipelines in Vietnam due to different factors. I will explain you what are these factors that we are considering, and that's also what defines our scope of the work. So these are the three factors that we are considering when we are analyzing the risk analysis of natural gas pipeline operations in Vietnam. Our first risk factor is the risk of the oil and gas pipeline corrosion. The second is the harsh weather conditions. The third one is the oversight of the pipeline management. This also includes the maintenance of the pipelines. So these are some of the diagrams which we adopted to show you what are the underwater gas pipelines looks like. These are the gas pipelines, and how does their leakage look like? As you can see here, I just want to emphasize here that this is the leakage in a gas pipeline which is underwater. So we developed two studies here in our work. The first was line 1, which has these properties. We have the design pressure of 10 megapascal, diameter of 711 millimeter, and the length is 43.8 kilometer. Now the first pipeline, we are studying the effect of the rupture, and the second one we are going to study the effect of the puncture here. And these are the two transmission pipelines in Vietnam that we are looking to work on. And then we made some comparison about the risk assessment and find out either rupture is the main cause of the release, or it is a puncture. Now these are some of the steps of our methodology. First, we define our system, which is looking to find out the gas release caused by a rupture and the puncture. There were 21 primary events associated with this. In the second step, we develop a fault reconstruction and analysis. I will come to this fault reconstruction in my next slides. Basically, it defines as the probabilities of the primary events, and it links them through some logical gates. And we can identify what are the probabilities of the gas release, which is considered as a top event in a fault tree. The third step is the conversion from fault tree analysis to Monte Carlo simulation. We used a tool which is called crystal ball software. The fourth step was to use of the logic gates and defining some assumptions here. Now let's talk about what is the fault tree. In the fault tree analysis, basically it is a structured approach where a deductive technique is used that follow a top-down structure with a well-defined accident or top event. It is used in the development of the causal relationship leading to the top event, which is normally considered as a risk. A risk is something which is unwanted event or unwanted scenario. The third fault tree analysis point is that the probabilities of the basic events enable the estimation of the likelihood of occurrence of the top event. And the next point is we use the Boolean logic gates such as AND and OR gates. I will also explain you what are these gates in terms of safety and risk engineering. So these are the gates here. As you can see there, this is my AND gate. This is how an AND gate is developed. Now, in order to have the success of the failure, both event should be successful. If any one of these is a failure, then the top event will be a failure. Now, in the OR gate, it is totally opposite scenario. Any one of the bottom event should occur in order to have the top event occur. And these are the algorithms. If we are using an AND gate, we need to multiply the probabilities of the basic events. In terms of the OR gate, we need to add up their probability and we need to subtract the product of their probabilities. And if it is a top event, it is indicated like in this diagram. If it is an intermediate event, it is again indicated through a special sign, and the basic event is always a circle here. I will also explain you these ones when we go to our fault tree analysis of this work. Now we use a crystal ball software to perform some risk analysis and assessments. It is built-in adds-on software in the Microsoft Excel. We can also simulate and perform the sensitivity analysis where we need the input of from the basic event, and we measure the sensitivity of the important factors that can affect the top event. And here our objective was to assess the probability of the damage to the pipelines. So what are our results here? Now this is our fault tree. As you can see that this is my top event, which is the gas release. It is connected from some basic events. These are my basic events here. All of these are my basic events. And where are the gates here? These are all the gates which you are looking at in the orange color. So this is my OR gate symbol, as I mentioned you previously, and this is my AND gate symbol. So what we do basically, let's say we have this tree here. We have the probabilities of the basic event pointed out. I will just show you in my next slides. And because this is an OR gate and I just show you what is the algorithm that we are using for the OR gate, So we can find out the probability of the tensile stress. Once we have the probability of the tensile strength, there is a basic event which is called corrosion medium here. So now this tensile strength, as we can see, it is indicated as an intermediate, but once we find out its probability, this probability and the combination of the corrosion medium, that what gives us the top event probability, because and they are linked to the AND gate, and in the AND gate I need to multiply the probabilities of these two events, and this is how we calculate the probability of our gas release. Now these are some basic event probabilities which we adopted from the literature. If you are interested about how we find out these probabilities, you are welcome to read our research articles, which I believe will be published very soon in the conference. Team will be more able to explain you the timeline about that publication. Now these are some of the results here. The most important result is my gas release probability, which turns out to be 0.0247. So there are 2.47% chances that the gas can be released, and these are the probabilities of some other events. Now if we come to our results, we see that our unreliability value is 0.02429. That is what is the probability of the gas release in underwater pipelines in Vietnam. And as I mentioned you earlier, we were interested to find out either rupture is the main failure or it is the puncture. So you can see that the value of the importance of GT2 is much higher than GT1. So the rupture of the underwater pipeline is more likely to happen as compared to the puncture. So according to our this short part of the research, we find out that rupture of the underwater water pipeline is a major could be a major issue in Vietnam gas pipelines. And these are some of the results of our simulation, where we find out that the 95th percentile probability of the gas release in pipelines could range from 0.0222 to 0.0268. So this is the 95th percentile probabilities. And through this analysis, the main factors which affect the gas release are defect of the pipe in both type. Either we are studying the rupture or puncture. It could be the fluid impact is the second one, and the dredging is the third most important factor. So what is our conclusion out of this study? This study studied the risk of the gas release in underwater pipelines in Vietnam by integrating fault tree and Monte Carlo simulation. Our results show that a comprehensive understanding of the hazard that may cause a gas release in the water pipeline is needed for safe gas transportation in Vietnam. Now, this is our ongoing work. Our group is also working on some other risk assessment techniques, such as the Bayesian network analysis, to predict the pipeline failures in Vietnam. And we are also looking at the subjective nature of obtaining the probabilities, because as you saw that the probabilities are the very most important aspect in faulty analysis. The same is true in the Bayesian network analysis. And further, our work can be done by integrating the bow tie updating techniques into the Bayesian network structure for comparative analysis. This is something that we are planning to do in the future. And these are some of the references. And I would like to say thank you to every one of you, and we apologize we are not present online at the moment, but this recorded presentation will be good enough. If you have any questions, you can email us, and we would also like to invite you to read our research articles to understand our current work, and we will be happy to respond to any of your queries you have. Thank you very much everyone, and have a wonderful day.